In part 1 of this lesson, I'll show you 3 separate examples where we find the partial derivative of a function. A few things you need to know before we get started is that to find the partial derivative of, let's say our function is z and it's in terms of x and y, to find the partial derivative with respect to x, you must regard all y variables as a constant and differentiate the function with respect to x. And the opposite is true if we want to find the partial derivative with respect to y. You regard all the x variables as constants and you differentiate the function with respect to y. In addition, keep in mind that partial derivatives can be denoted in different ways. My preferred way is f sub x and f sub y, but it's also denoted using this symbol, which is a stylized version of d. And it's not to be confused with the Greek letter delta. It's not the same. It's just a stylized d. So f sub x is the same thing as this, and it's read the partial derivative of our function f with respect to x. That being said, the question reads, find the partial derivatives of the following functions. So we'll start with a, and they want both f sub x and f sub y. Now keep in mind that these might take a while to do, especially given the complexity of the function. So you really need to know how to find the derivative of functions to be good at this. So starting with a, we want to find f sub x. This y will be regarded as a constant, this one, and this one. Keep that in mind. We'll take the derivative of the first term. We have e to the power of x to the power of 3 plus y to the power of 2. And then we take the derivative of this part, that expression, and we'll multiply it to this expression. X to the power of 3 becomes 3x squared. We're using the power rule. And y to the power of 2 becomes 0. Remember, it's a constant. It's like taking the derivative of a number. Next, we move on to this term. We have plus, using the power rule, 5 times 2x, and we subtract 1 from this power 2. And y, think of it as a constant, will be written as a factor of that term. Finally, moving on to this term, we have plus y to the power of 3. Y to the power of 3, think of it as a constant, becomes 0 if we take its derivative. Now if we clean this expression up, we should end up with 3x squared times e to the power of x to the power of 3 plus y to the power of 2 plus 10xy. Now let's find out what f sub y is. And this time, this is considered a constant. So is this. And that doesn't apply to this term. We'll take the derivative of that first term, e to the power of x to the power of 3 plus y to the power of 2. Now we take the derivative of that. X to the power of 3 becomes 0, and y to the power of 2 becomes 2 times y. Moving on to that, if we take the derivative, and if we think of 5 and x squared as constants, and y is our only variable, taking the derivative of y makes it 1. So this whole term becomes plus 5x squared. And this term becomes, if we use the power rule, 3y squared. Let's move on to question B. In question B, they only want us to find f sub y. Now, if you want to find f sub x, it's going to take a while, because to find the derivative of this term is not easy. It takes a while. You need to use a quotient rule. So luckily, they've asked us to find f sub y only. Question B, f sub y, and that's the same thing as saying the partial derivative of our function with respect to y. So let's begin. We'll start with this term, and if we take the derivative with respect to y, this y becomes 1, and we're left with the fraction x squared plus 3x over sine x to the power of 3 minus, now let's focus on that, the derivative of cosine is negative sine. So we have negative times negative sine. This part stays the way it is, 2xy plus y. And we multiply it by the derivative of this expression. And since it's with respect to y, this term becomes 2x, the y goes away, and this y becomes 1. You can clean this up further, but that's not necessary. Technically, we've done our work and we found the derivative. Lastly, for question C, they want us to find the partial derivative of this function with respect to x. We have arctan, that's another way of saying tangent inverse. And the derivative of tangent inverse is found right here. Technically what you do is you take the content and place it right into where you see the x, and then find the derivative of this part, multiply it to this. So with that being said, we'll write down the partial derivative of our function with respect to x is equal to 1 over 1 plus, and I'll replace this expression into there, x squared t. Remember, I'm taking both of these factors as powers of 2. So x to the power of 2 and the square root of t becomes simply t. And I'll multiply that to the derivative of this part. Remember, t is considered a constant in this example, whereas x is not. And the derivative of x is 1, leaving us with just the constant, the square root of t. Therefore, our answer is the square root of t over 1 plus x squared t. And there you have it. 3 examples on how to find the partial derivative of a function. For more of a challenge, make sure you watch part 2 where we explore more types of examples related to this concept. We'll see you soon.